Hello and welcome back to another video. In this problem, we're told an isotope of sodium has a half-life of 15 hours. A sample of this isotope has a mass of 2 grams. So in part A, we're asked to find the amount remaining after 60 hours. So if this isotope has a half-life of 15 hours, that means every 15 hours, the amount of the sample is going to be cut in half. So 0 hours in, the mass is 2 grams, right? That's what we're starting out with. And then 15 hours later, it's been halved, so 2 grams to 1 gram. Then we do another 15 hours, so 30 total, and the amount that was available at 15 is a halved again, so 1 to 0.5. Next, 45 hours, halved again to 0.25. And finally, all the way up to 60 hours, halved once again from the 45-hour mark, and we get 0.125. So this is the amount remaining after 60 hours. B, to find the general amount remaining after t hours, what we have to do is create an equation that follows this pattern. So this is an exponential function, and we can call it f of t, for example. F of t is equal to the original amount, 2, times the rate of change, which is 1/2. It's being halved every t hours. We take 2, and then we multiply it by 1/2 every time the t goes up by 1. However, that's not exactly what we want. We want the half-life to be 15 hours. So we only multiplied by 1/2 if t goes up by 15. So if we divide the exponent by 15, then when we are calculating this function, and let's say t is equal to 60, 60 divided by 15 is 4. So for 60 hours, we are multiplying by 1/2 4 times, which you can see that we do here, 1, 2, 3, 4. So this is our function. So this side is the amount remaining. C, we're asked to estimate the amount remaining after 4 days. 4 days is 48 hours. So we have to calculate f of t for 48. I'm going to do this in conjunction with part D, which is to use a graph to estimate the time remaining for the mass to be reduced to 0.01 grams. So in this graph, which I have drawn up in Desmos, we can see that we have the general exponential shape. It's pretty zoomed out, but you can see it. And I have these 2 lines here in place. So the first here is this green line, x is equal to 48. So this x value of 48 represents the time when we are at 48 hours. And if we zoom in, at 48, the function has a value of 0.22. Therefore, there is a mass of 0.22 grams, or 0.218, remaining at 48 hours. So that's the answer to C. And then in part D, we are asked for the value when the mass is 0.01 grams. So the number of days it takes to hit 0.01. And I have drawn this blue line here is not the y-axis. It is the line y equals 0.01, right? So you can see if I zoom in a lot, we can see that point. But it's really hard to find the intersection point because they run so close to being parallel. It takes a very long time for them to actually get close to each other. So what I did was I set the function equal to 0.01. And if you do that in a graphing calculator, what that does is it gives you the x value of the intersection point. And that x value is represented by a line. This line, if we look here, and then zoom in, this will give us the actual intersection point, which we can see is a little over 114 days. So at 114 days, it will have been reduced to 0.01 grams. So our 2 final answers. At 48 hours, we are left with 0.22 grams, and it takes 115 days, rounding up, to be reduced to 0.01 grams.